Okay, we're looking at Prep Test 65, December of 2011, and this is LSAT Logic Game 2. As part of an open house at a craft studio, 3 teachers, J, K, and L, will give 6 consecutive presentations on 6 different subjects. J will present on N and O, K on P, S, and T, and L on W. So J on N and O, K on P, S, and T, L on W. Okay, so what I should already have identified there, okay, sequential game with a grouping aspect to it. Basically, I have a sequence of how things are going to be presented. There will be a sequence of those. And in that, the grouping feature to it is who will be the presenter. Okay, so I'm going to have a setup that looks like this. Okay, and then what I will do is just put something on the top and the bottom. On the bottom is going to be the people who are the presenters, either J, K, or L, and on top will be the sequence. And we have a 1-for-1, so we don't have to worry about things that actually aren't going to happen, so that's a good thing. We just have to basically have a sequence of 6. Okay, let's move forward. The order of their presentations will meet the following conditions. K cannot occur consecutively. Okay, I represent it like that. You can even write, you could have written down K can't go consecutive, whichever way that you would like to look at it, okay? The second one, the presentation on S must be given earlier than the one on O. So S is before O. And then lastly, the presentation on T must be given earlier than the one on W. Okay, so as always, we want to try to utilize first, second order rules, so on and so forth to solve the scenarios. And we should see right here, we don't really have any first order rules or second order rules. We have some third order rules. But we have this glaring thing right here that says that K cannot occur consecutively. And so we need to be able to make the deduction. Guess what? K has to do 3 things. So if K has to do 3 things and there are 6 spots, how many possibilities are there when K can't touch? And this is just something that you should pick up on. You should know this is a numerical distribution trick, and it is the key to the game. So the only way to get through this game, in my opinion, is to understand exactly what's happening here. All right, so I can do that. All right, and if I kept K, the first 2 Ks in the same spot, I could move K over 1. And then lastly, if K is going first, if I kept K first and this guy is exhausted, I could move this K over 1. Okay, that's all that can happen with regard to K going first. And then I could have K going second, 4th, and 6th. Okay, so I have exhausted out what I know from this rule. And then let's just kind of take a look at S and O and T and W. And you should notice that, guess what? S and T are in the K group. So P, S, and T are going to occur where the K's are. Okay. Now, because S and T, something has to go before them, I know that whenever K's last, that forces P. P must occur here. Okay. There's no other way, nothing else can happen. If I were to put S or T, then we couldn't have the O or W that inherently must go in front of, or right after both of those. Okay, so let's just concentrate on this. We don't really know what S and T can do after that, so we can just put an option. Okay, and at this point, the only thing that we should really be thinking about is, okay, we know that O and W have to occur after S and T, but you know, depending on who went here and who went here, there's a lot of things that could happen. I'm not going to really focus so much on it, but if we look at the last one, we know that O and W, whichever their order, whichever this order will be dependent, what we do know for a fact is that N would occur here. We know that, because we know that both O and W have to go in this spot depending on what happens with S and T. Okay, and then with regard to this one up top, we don't really know a lot that can happen here because P, S, and T can go in any order, okay? So I'm going to stop right here. I've made some scenario templates, okay? I've identified the key feature to the game, and I'm not going to burden myself with trying to solve it out. I could split this apart and end up with a number of scenarios, but I've got the bare bones thing to work with that will tell me where every answer must come from. We know for a fact that whatever scenario we're given, it has to derive from one of these four situations. Okay, so let's now go to the questions and see what we come up with. Which one of the following could be the order of the presentations from first to sixth? Okay, so this is a list question, and we know that with this we try to identify the incorrect answers by going through the rules, and the last answer choice standing is obviously the correct answer to the question. Now, because we're thinking about K here and it can't go consecutive, the way that you'd have to identify that is you'd need to look at and see if P and S are together, if S and T are together, if P and T are together, okay, if they're somehow touching. So that's kind of complicated. Let's hold off on this rule because it requires like 3 rules in one really. And let's go to the easier rules first. So let's see if we can eliminate a couple of answer choices, and then we'll have a limited number of answer choices to have to look at, okay? So if we look at the second rule, S must occur before O, okay? We see that it happens in A and B, it happens in C, it does not happen in D. O is actually before S, so D falls out, okay? And then we look at E, we see it happening in E as well. So D is the only incorrect answer there, okay? So we've eliminated that. Then let's look at the third rule, T must occur before W. Well, if we look at B, we have W occurring before T. Okay, so now it's time to go back and look at this dreaded, really 3 rules in one. And what we're just looking to see, you know, it's kind of difficult. We want to try to identify the patterns here, and we just want to see if we can have, if we see P, S, or T somehow touching each other, that's gonna give it off. Okay, so if we look at A, we have P and T touching, so A's out. Okay, now we're just looking at C and E. Okay, and if you look at, let's look at C, we see S going first, T going third, and P going sixth. Well, we have that happening right here, first, third, sixth. That's valid. Okay, so let's look at E, and if we look at E, we see T and S touching, so E is out. We're left with C. What I consider to be a little bit more difficult of a list question than normal, but just always remember when you see things like that, do the easy ones first, try to eliminate it out. That way we only had to apply this rule 3 times instead of having to apply it 5 times. Okay, let's go to question 7. If T is presented in fifth, which one of the following could be true? Okay, well, let's just look through here. Actually, I have this written incorrectly. Where do we see T, the possibility for K to go fifth? And it's only here. Okay, so at this point in time, I'm basically going to be writing right on the side of my answer sheet, and I just bring it over. And when I say answer sheet, I'm writing right on the side of where the question is. I've just moved up and said, okay, this is what I've got. I'm not ever messing with my templates. This is the deal. Well, if I know that if T were to go there, right? Well, then I know that W has to go here. That's for sure. And then we just basically have P and S and P. I could split this out and do a little bit more with it. If I was to move P and S and P, then I could actually make 2 scenarios here. I don't think it's really necessary. We see what's happening, so it asks us which one of the following could be true. A, N is presented 6. That can't be true. We know it has to be W. Let's look at B. P is presented 4th. Well, no, we know that P has to go first or third. Let's look at C. S is presented 2nd. That can't be either. We know that S has to go either first or third. D, S is presented 3rd. That absolutely could be true. D is the correct answer to the question. And then let's look at E. W is presented 2nd. Well, we know that if T is here, W has to go after it, so that can't be the answer. Again, we've proven that the correct answer to the question is D. Okay, 8. If N is presented first, which one of the following could be true? Okay, well, if we look through here, On every one of them, K is going first, and it's either going to be P, S, or T. But on this one, this is where we have N, and actually N must go first in this situation. So what, which one of the following could be true? A, O goes 6. Well, no, we know that P has to go 6. B, P is presented second. Well, no, we know for a fact that P has to go 6th again. Okay, C, S is presented third. Well, no, we know that we're on 2, 4, and 6. So P, S, or T are not going to be occurring on odd numbers. Okay, D, T is presented fifth. Same situation. And then E, W is presented third. Absolutely. If we had W here, we'd know that T, we'd have a T and W, and then an S and an O. But we know for a fact that E is the correct answer to the question. Hopefully, this is a very, very difficult game if you don't see this pattern. And if you didn't see it, you just need to keep practicing. You'll see this sort of pattern come up a number of times. This numerical distribution, that's really all that they're hounding on this particular game. Okay, and J cannot give both the first and third. So all we're really looking at here, when we're asked this question, is to figure out what variables does K have to occur. If I give you two variable locations, where is it that K would always have to be in at least one of those, okay? So if we look at A, the first and third, well, you know what? The first and third, K don't have to be there, so J could possibly do the first and third. So because it's a cannot be true, that's not the answer to the question. Let's look at B, the first and fourth. Well, is there any situation where both the first and the fourth are not given up? Well, we know that the first is done here, so we're down to here. If the first isn't here, but the fourth is there. So the answer to the question is B. J could never give both. N and O could never occur both first and fourth. And again, that's because no matter what happens, K will have to be in at least the first spot. And if it's not in the first spot, it's going to have to be in the fourth spot. So B is the correct answer to the question. Let's keep going, though. C, the first and fifth. Well, yeah, it could do that because it's wide open there. All right. Again, I'm not looking at the first here because the first is always used up by K, but first and fifth could happen there. D, the second and third presentations. Well, look right here. We could do the second and third because we're going 1, 4, and 6. Okay? And then E, the second and fourth. Yeah, sure. If we went 1, 3, 6 or 1, 3, 5, J could do the second and the fourth. So again, we've proven that B is the correct answer to the question. It cannot be the case that J gives both the first and the fourth. N and O could never go first and fourth. Okay, let's look at 10. If N is presented 6, which one of the following must be true? Well, where can this occur? It can only occur in the first one. So we're back to having to, we have to make one. We're going right next to the question. Okay, we know the exact template from which we have to work, and we know that N is there. Okay, well, what do we know if N is there? We know that S and T, something has to go before both S and T. So if N is here, we know that P would have to occur here, and then we're at this. And then it's just dependent on if S were to go here, we know O and W. If T were to go here, we know W and O. So that's the only thing that can happen. Let's see what the answer choices bring. A, so it's what must be true. A, O is presented fourth. That doesn't have to be true. It could either be O or W depending on what S or T does here. B, P is presented fifth. Absolutely, that must be true. That's the correct answer to the question. Let's look at C, though. S is presented third. Well, we know that S could go either first or third. And then let's look D. T is presented first. Again, T could go first or third. And then E, W is presented fourth. And again, we don't know what W does until we know what T does. So the only one that must be true is B. If N is presented last, it has to be the case that P is presented fifth. Okay, number 11. Which one of the following cannot be the subject of the second presentation? Okay. Well, let's take a look. We know that it can be S and T, S or T. Okay, so we have eliminated D, And then, so the idea, I think this is a pretty tricky question because it appears to be pretty wide open as to what can happen. We know it's S and T. What are the only variables that we basically have been that we've been working with the whole time? It's P, S, and T. Okay. Well, when we have the 2, 4, 6, we know for a fact that P has to be last. P can't go second. And then we need to ask ourselves: is there any other time that P could even possibly go second? It never could because of the K's. They're at 135, 136, and 146. That's the only place P could go in those situations. So we know for a fact P could never go second. The only time that the K's can go second, P has to go last. So the answer to the question is C. At this point, I would be done, and I'm moving to the next question set. But let's just, to make sure that we're clear here, we've proven P. We know that T's out. We're looking at N, O, and W right now. Okay, well, let's look at these little scenarios we've made here. We could have an S, O, T, and W, okay, or a T, W, S, and O. That means that O and W are free to go second. We've just proven that. So B and E are out. And then let's just look at N. What could happen here if we had a P here? We could do a P and an N here, okay? And this would be PNSO, okay? And that proves that N could actually go. So A would fall out, and the only one that actually cannot happen is P. We already ascertained that given what we had, but I wanted to go through just in the event that you had some sort of confusion. Okay, so this game could be extremely difficult if you didn't understand this simple distribution. And what you should be thinking about in your head is if it ever says there are 2 consecutive things that can occur, and then you're looking and saying, wait a minute, there are 3 variables, there's only 6 spots, bam, you should be thinking about the 4 things that can happen. Okay? All right, that concludes Game 2, Prep Test 65, December of 2011.